Welcome to the office. We want to take a look at direct products and finitely generated abelian groups today. And this idea of a direct product, so G1 times G2, right? I've used this multiplication symbol, although really we don't use that symbol very much at this point in higher level mathematics, right? We use a dot for multiplication or nothing for the implied multiplication. But this notation might look familiar to you. If you think back, discrete math, maybe at the beginning of this course or in the proofs course, you talk about this idea of a cross product or a Cartesian product of sets. And it's exactly the same thing that we're working with here. We just then apply it to the case where the sets are actually groups. So we want to take a look at that, which is just the next page here. So the Cartesian product of sets S1, S2, all the way up to Sn is the set of all ordered n tuples, okay, A1, A2, all the way to An, where each AI comes from Si. So A1 comes from S1, A2 comes from S2, and so on. The Cartesian product is denoted by either this, so in many cases, right, we've got, we'll talk about groups, so G1 cross product with G2. So we'll write that. In the case that there's a large number of them, we could write it in this way. And this actually is product notation. So for example, this notation you might not be familiar with. It's not used in many texts. But if I were to say something like I equals 1, 2, 3 of, let's just call it I squared, this would actually be 1 squared times 2 squared times 2, there we go, times 3 squared. So 1 squared is just 1, of course. 2 squared is 4. 3 squared is 9. 4 times 9 is 36. So we're familiar with sigma notation, the sum from 1 to 3 of I squared, right? We were familiar with that, but that's summation notation. This is product notation. And since we're looking at a Cartesian product, hey, look, yep, that makes sense. Product notation for a product. All right. So we want to find the Cartesian product of these sets, A and B here. So this is the Cartesian product, then determine the cardinality of the set A cross B. So if I want A cross B, I am looking at a set of ordered pairs. So I'm just taking things that belong in A and pairing them with things that belong in B. So I could say 1A, 1B, 2A, 2B, 3A, 3B. So pretty simple. Oh, don't forget the comma there. But that gives us our cross product, A cross B. So there are 1, 2, 3, 4, 5, 6 elements in that set. So the cardinality of A cross B is exactly 6. Again, cardinality for a finite set is just the number of elements in that set. And so a quick question for you that I'll leave for you to answer. And here's a hint. Multiplication. C missing in there. Multiplication. There we go. Principle for counting. What does the multiplication principle tell you? Multiplication principle for counting tell you about how many elements should be in this cross product. Right? Think of it as how many things can I plug into the first entry, how many things can I plug into the second entry, and that will tell you exactly what you're looking for there. All right. So really quick, that was just a Cartesian product. Let's move on in the next video to what a direct product is. So I'll see you guys back here in just a moment.